assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
Okay, so for this question, we're going to use the Rydberg equation, which is 1 over the wavelength equals r, which is the Rydberg constant, times 1 over m squared minus 1 over n squared. So when we talk about the Balmer series, and quickly, this is also called the Balmer equation too. Or Rydberg equation. When we talk about the Balmer series, we talk about an electron dropping to m equals 2. So we're going to set our m to 2, and then we're given that n equals 6. So from there, we just need to solve for our wavelength. So let's go ahead and plug in what we know. We know that it's 1 over the wavelength equals r, which is 1.0974 times 10 to the negative second. I'm going to leave off my units just because I'm very slow with writing, but you should always write out your units. And then we're going to say 1 over 2 squared minus 1 over 6 squared. All right, so if we go ahead and solve this, we are going to find that the wavelength equals 410.2 nanometers. All right, so since we have the wavelength, we can now use this equation, E equals hc over the wavelength in order to find our energy. And we know we want it in kilojoules per mole, so we know we're going to have to multiply this by Avogadro's number to get it. Ooh, that is a very big N. Multiply it by Avogadro's number to get it into moles. Great, so let's fill in what we know. So we know h is Planck's constant, which is 6.6 times 10 to the negative 34th. We know the speed of light is 3 times 10 to the 8th. And for Avogadro's number, we know it is 6.02 times 10 to the 23rd. And if we want to fill in the units for this one, just so you can see where we get moles, Avogadro's numbers is really just 6.02 times 10 to the 23rd things over moles. So in this case, we want photons because we're dealing with energy. So it would be 6.023 times 6.02 times 10 to the 23 photons over moles. And then we want to put in our wavelength again. H is in joules, and we have a wavelength in, or I do this every time. The speed of light is in meters. So we want to get it to, we want to get our wavelength into meters as well so that our units match up. So we're going to say, since it's in nanometers, if we multiply this by 10 to the negative 9th, we are going to get this in meters. So if we go ahead and solve for that, we are going to get 292 kilojoules per mole. And you know what, now that I'm saying this, kilojoules per mole, Planck's constant is in joules. So in order to get this into kilojoules, we are just going to say 1,000. Oh, sorry, not what I wanted to do. Boop. 1 kilojoule is 1,000 joules. Or you can just divide the answer you get for this portion by 1,000 to get it into kilojoules.